Section 4.2, thank you for your patience. Section 4.2 is talking about using matrices to solve systems of equations. So we're going to revisit the idea that we just learned in section 4.1 about solving systems of two equations and two unknowns, and we're going to interpret that in terms of this new idea called a matrix. Okay? So, goal is to learn how to use matrices to solve systems of equations. So let's start out with some terms or a note. Suppose you are given the following linear equation. I'm going to zoom in. There you go. Suppose you have a1x1 plus a2x2 plus everything out to an xn equals b. The numbers a1, a2 out to an are called coefficients. They are called coefficients. And then B is called the constant term. Make sure your noses are covered with your masks. B is called the constant term, or sometimes just the right-hand side. Okay? A matrix is a rectangular array of numbers. So an example here is taking this square. You said rectangular. We can just make it the same size, the same number of rows and columns, and we can just put numbers inside. This has 2 rows and 2 columns. This is an example of a matrix. And you might be thinking of the movie, but yes, this is the same idea here. Okay? The augmented matrix, of a system of linear equations is the matrix whose rows are the coefficient rows of the equations. The augmented matrix of a system of linear equations is the matrix whose rows are the coefficient rows of the equations. So let's look at an actual example of this concept. So for example 1, provide the augmented matrix for the given systems of equations. So here we have the system of equations 2x plus y equals 2 and negative 2x plus y equals 2. The definition says the augmented matrix of a system of linear equations is the matrix whose rows are the coefficient rows of the equations. So the first row will be the coefficients of the first equation. Does that make sense? So I'm going to draw a matrix here, the brackets for a matrix. How many columns are we going to have? I see people saying 2. Sorry, what? I see somebody saying 3. Why 3? Talk a little bit louder. Because there are 3 coefficients. What are they in the first equation? 2, 1, and 2. So your augmented matrix has all of the coefficients of your entire equation. So 2, 1, and 2. That's the first row here. What's the second row? Negative 2, 1, and 2. You got it. Very good. So this equation has how many rows? Talk. 2 rows. How many columns? 3. Okay? We say the size of this matrix is a 2 by 3. So we do the rows by the columns. We don't multiply them. We just say the rows by the columns. So I'll talk about this eventually, but while we're here, might as well go ahead and introduce it. The size of the matrix, the augmented matrix, we'll use our words. The size of the augmented matrix in example 1 is a 2 by 3. So 2 rows, 3 columns. What questions do you have? Yes?
So for the third column, that represents like the constant of, okay, so you still include the constant.
So that's the augmented matrix. The augmented matrix definitely includes the constant term. The augmented matrix includes the constant term. Absolutely. What other questions do you have? Okay. Part B. Part B, given that system of equations there, write the augmented matrix for that system. Take a minute. What's the size of this augmented matrix? 2 by 3. Let me not move this. I'm trying to write. So 2 by 3. Very good. What's the first row?
2.
Very good. 2, negative 3, 1. And what is the second row?
6, negative 9, 3.
Very good. 6, negative 9, and 3. Okay, so that is the augmented matrix for that system. Now what we're going to do, we're going to go through an example where we are going to solve each system of equations using the method from section 4.1. And then in the next example, we're going to start using the new method, using matrices. Okay? So this is to lead us up to how to connect the two. Yes, your question? So the question was, can we simplify this matrix here? No, we cannot simplify that. Okay? It is what it is. Here, the augmented matrix is just this. Now, if we want to solve a system, then it's going to involve other steps in solving. And that's what we're leading up to. What other questions do you have? Okay, so let's look at example 2. Example 2 says solve each system of equations. Okay, so here we have 2x plus y equals 2 and negative 2x plus y equals 2. What can we do? Use the elimination by just doing what? I can't hear you. By doing what? Canceling. Do you have to multiply by anything? What do? What do you do to the rows? Add. Good. You add the 2 rows. So you add the 2 rows. So 2x minus 2x is? Y plus y is? And 2 plus 2 is? 4. So 2y equals 4. And now we're going to do what? Divide by 2. Notice that I'm writing down the steps that we're doing because we're going to need to know the steps whenever we're learning this new method. Okay, so it's important to remember the steps that you're taking to get there. So we're going to divide by 2. So dividing by 2 gives us y equals what? 2. Very good. Now we're going to substitute y equals 2 into, you can use whichever equation. You want equation 1 or 2? Into equation 1, which is this one. We get 2 times x plus 2 equals 2. There's no need for the parentheses. You have 2x equals 2 minus 2. Or 2x equals what? 0. Or x equals what? 0. So your solution is what? So what is it? 0, 2. It's the pair 0, 2. So make sure you put parentheses around that. Good. What questions do you have here? Okay. Part B. Part B, we have 2x minus 3y equals 1. And then 6x minus 9y equals 3. How can we solve this system? Yes?
Well, first can we start by multiplying the top one by negative 3?
By negative 3?
Yeah.
So multiply equation 1. So we're going to multiply equation 1 by -3. So that's going to give us -3 times 2x minus 3y equals -3 times 1. And then we're going to have our second equation that stays the same. And then we rewrite our system. We get what? Distributing the -3, now what do we get?
Negative 6x
Equals -3, good. And then our second equation stays the same. And now we do what? Now we add. Go ahead. Okay, so now we add the two rows. What do we get? 0 equals 0. What does this mean? Say it again. Good. So there are infinitely many solutions. Okay. Note that you could be asked to parameterize this by x or y and provide a general solution. It's the same as what we talked about before. Okay, so you will see stuff like that in your homework. Okay? Now we're going to apply a new method. We already know that when we solve this system, we should get what? We should get the solution 0, 2. But now I'm going to explain it to you using your augmented matrix. So make sure you pay close attention. Okay, make sure you pay close attention. Okay, so what we're going to do in example 3, we're going to do this. Let me zoom in just a little bit. Okay, so we want to solve each system of equations from example 2 using the respective augmented matrix. The augmented matrix for this system is what? Give me the row. 2, 1, 2. -2, 1, 2. Good. Sometimes people draw a dotted line to separate the x and y terms from the constant term. Some people do this. Okay? Notation, let me explain some notation to you. R1 means row 1. R2 means row 2. Okay? And then what we can do, we can add rows, we can multiply a row by a number or constant, and then we can add rows, subtract rows if we want. Okay? So the way we're going to solve this, now what we want to do, we ultimately have to get this matrix into this form if we can. 1, 0, 0, 0, 1, 2. Because what this would mean x plus 0 equals 0. So x equals 0. And this would mean 0 plus y equals 2, or y equals 2. Does that make sense? So that's what we want to do. That's our goal. So what we're going to do, we're going to box this 2 and use it to help us create a 0. So we're going to add, I'm going to write an arrow and say we're going to add row 2 plus row 1 to get a new row 2. And if you just want to pay attention and watch the video to fill in your notes to see what's going on, feel free to do that. Okay? So we start out with row 2 because our goal is to change this to a 0. We're going to say row 2 plus row 1. This arrow means to get a new row 2. So row 2 is changing. Row 1 is not. So row 1 is going to stay the same. So we get 2, 1, 2. Now, row 2 plus row 1. Negative 2 plus 2 is what? 0. So this is going to change to 0. 1 plus 1 is 2. That's where this 2 comes from. And then what's the last one going to be? 4, because 2 plus 2 is 4. You got it. Okay? So what we did was we said row 2 plus row 1 to get a new row 2. Does it help for me to write this out on the side? Okay, so I'll do that. Next up, what we want to do is we see we can make this here a 1 by multiplying row 2 by 1/2. So we are going to say 1/2 times row 2 to get a new row 2. And you put that arrow there. First row did not change, so you have 2, 1, 2. Then we have 0. What's the next one? What is it? 1, good, and then 2, good. So we've created a 1 here. Now what we're going to do is we're going to use this 1 to create a 0 here. Okay? So now we're going to use this 1. But before I do that, let me write down what we did. So we multiplied row 2 by 1/2 to get a new row 2. Okay? And now what we're going to do is we're going to create a 0 here. So now which row is going to change? Row 1 or row 2? Row 1. So you always start out with the row you want to change. So row 1 minus row 2 to get a new row 1. Okay? So, we do our arrow. Now we're doing row 1 minus row 2. 2 minus 0 is 2. 1 minus 1 is 0. And what's the next one? Sorry, I can't hear you. 0. Good, because we're doing 2 minus 2. So we get 0 here. In the second row, did the second row change? No, so we write down 0, 1, and 2. So the only thing left is to make this 2 a what? 1. How can we make this 2 a 1? Can't hear you? Excellent. Multiply by 1/2. So I forgot to write. Let's write subtract row 2 from row 1. That's what we did. And now what you said is multiply row 1 by 1/2 to get a new row 1, which was absolutely correct. And when you do that, we get 1, 0, 0, 0, 1, 2, which is exactly what we wanted, right? Because this says x equals what? So x equals what? This says x plus 0 equals 0. So x equals 0. And then we have 0 plus y equals 2, or y equals 2. So your solution is 0, 2, as desired. Okay? So this is how we use matrices, or use an augmented matrix, to solve a system of equations. Okay? We will continue this next time. Example 3 continued. Example 3 continued. What we want to do is solve this system of equations using matrices. We want to solve the system of equations using matrices. So we're going to write down our augmented matrix. What is that? 2, -3, 1, and
6, -9, 3.
good. Okay, what would you like to do first? Yes?
I was wondering, could you factor out 3?
Okay, let's start there. So you're saying multiply row 2 by 1/3 to get a new row 2. So, does row 1 change? No, it does not. So you have 2, -3, 1. What's your question? 3, 2, because 6 divided by 3 is 2. So you get 2, -3, and 1. Okay, now what are we going to do? What row do you want to change? Row 2? Good. You do row 2 minus row 1. So row 2 minus row 1 to get a new what? Row 2. Good. So now row 1 doesn't change. So now we're doing row 2 minus row 1. 2 minus 2 is what? 0. Then we're going to have -3 minus a -3. That gives us what? Careful. -3 minus a -3 gives us 0. So we get 0 here. And then 1 minus 1 gives us 0 as well. So for this example, it's impossible to get a 1 in this position. We have a row of zeros. But we can go ahead and create a 1 here by doing what to row 1? Multiplying it by 1/2. Very good. So 1/2 times row 1 to get a new row 1. And then we get what for row 1? You get 1. What's the next? -3/2 and 1/2. Good. What's about row 2? 0, 0, 0. So the way we interpret this is translating it back to equations. Can you still read that? Okay, so translating back into equations. So translating back to equations gives us the following. That's a V. Okay? X minus 3/2 y equals 1/2. So that gives us x minus 3/2 y is equal to 1/2. Here, the second equation is just 0 equals 0. That's all you get there. Because there is nothing here, you can solve this equation for x. So solving this equation for x means x is equal to 1/2 plus 3/2 y. And this row of zeros here means y is arbitrary. This means y is arbitrary. Y can be anything. Okay? So what we would do for this is parameterize. So the general solution parameterized by what variable? X. So our final answer is going to be in terms of x? Y. Parameterized by y is 1/2 plus 3/2 y, comma y. Okay, so this would be our final answer, which agrees with what we did in example 2, part B. Okay, so an observation here, an observation. When we have two equations in two unknowns, and and when we get a row of zeros, that means we have infinitely many solutions. Okay, so that's an observation from this problem. The method that we are using to solve these systems of equations is called the Gauss-Jordan method. It's called the Gauss-Jordan method. Okay? Got it? Yes? No?
Yep.
Okay. Example 4. Example 4. Use the Gauss-Jordan method to solve the given systems of equations. Would you like a minute to try it? Okay. Okay. So what is your augmented matrix?
2, -3, 2.
Yes. 2, -3, 2, and
6, -9, 3.
6, -9, and 3. Good. And you said you wanted to start at 1/3 times row 2 to get a new row 2. Whenever you did that, row 2 or row 1, it's a large matrix, row 1 did not change, so you have 2, -3, 2, but what did row 2 become?
2, -3, 1.
2, -3, 1. And what did you do from here? Yes?
I subtracted the 1 and
To get a new?
row 2.
Good. So row 2 minus row 1 to get a new row 2. And when you did that, row 1 didn't change. So you have 2, -3, 2. What did row 2 become? 0, 0, -1. And what can we say at this point? No solution, right? No solution. Good. Why? They're very good. 0 does not equal -1. So since, excellent work, since row 2 translates into a false statement, zero equals -1, there is no solution. There is no solution here. Okay? And that's it. So the observation for this page, is the following. If at any point in an augmented matrix row reduction, the process that we're doing, so this just a side note, the process that we're doing, this Gauss-Jordan method to simplify, is called row reducing. Okay? So at any point in an augmented matrix row reduction, if we have all the coefficients in the row are 0, and the constant term is another number other than 0, we have a false statement. Which means there's no solution. Okay, so that's the observation from this page. Does that make sense? Yes, no, yes?
Yeah.
There's a question? So So in part B of this example, what we want to do is we want to solve this system of equations. How many equations do we have this time? 3 different equations. How many unknowns? 2 unknowns. Okay, so let's think about this before we jump right in and start trying to row reduce or use the Gauss-Jordan method to solve this system. So we just answered it, but let me write that. So this system has 3 equations and 2 unknowns. Okay, so thinking ahead. If our matrix looks like, do you have a question? Okay. If it looks like the following, something here, something here, something there, something here, something here, something here, and then if we have a row of zeros, then we can actually get a solution for x and y, right? Because that'll mean you're able to get x equals something and y equals something, and then this row of zeros will just be extra, okay? However, if it does not look like that, it being your matrix, if your matrix does not look like this after row reduction or reduced row echelon form, after row reduction, we do not have a solution for x and y. Okay? So that's just thinking ahead. So ultimately, we would like to have our matrix in this form here. If we don't, then that means we won't get a solution. Are you with me? Okay? All right, so solving this system, let's put our matrix in an augmented form. What is that?
1, 1, 1.
1, 1, 1, good. Next row.
3, -2, -1.
Good. 3, -2, -1, and
5, -1, 1/5.
5, -1, 1/5. Good. Do you want to deal with fractions the whole time? So what we're going to do is we're going to eliminate this 1/5 here by multiplying row 3 by what? 5. Good. So we're going to do 5 row 3 to get a new row 3. That's going to give us the matrix. First 2 rows don't change, so that's 1, 1, 1. Do you prefer the dashed line in here or not?
Yeah.
Okay. Next row is 3, -2, -1. The third row becomes what?
25 -5
And what?
1.
1. Good. And then, so what we did was we eliminated the fraction in row 3. Now, what we can do here is we can create zeros here and here. So I'm going to box this 1 because we're going to use that 1 as our guide to create zeros here and here. So, row 1, this 1 is going to be called our pivot, meaning we're going to use it to get zeros here. Okay? So, to create a 0 here, we need to multiply row 2 or we can just leave row 2 and do, let me erase that and use red. So we will have row 2 minus 3 times row 1 to get a new row 2. And then, so that's 1, 1, 1. What is row 2 going to become? Want to walk through it together? Row 2, you have 3 minus 3 times 1, 0. Then we have negative 2 minus 3 times 1, negative 5, good. And then we're going to have random marks. Negative 1 minus 3 times 1. What do you get? Negative 4, good. Is everyone seeing this, or does anyone have issues seeing this? What I'm going to do is I'm also going to change this 25 to a 0 by using this as our pivot. Can you tell me what the operation is going to be? Good. It's R3 minus 25 R1 to get a new R3. Did you want a minute to write it out? Okay, I'll give you a minute to. What do we get?
0, -30, -24.
Very good. Did you make any observations yet? You said yes? What's your observation?
Well, I just thought of something to do that.
What did you think of?
R3 minus 6 times R1, R2.
R2?
Yeah.
To get a new what?
R3.
R3? Okay, so let's try it. Row 1, is that going to change?
No.
Nope. So we have 1, 1, 1. Row 2 going to change? No, so we have 0, negative 5, negative 4. Ignore the word observation. And then we're going to do row 3 minus 6 row 2. 0 minus 6 times 0 is 0, good. And then negative 30 minus 6 times negative 5 is 0, good. So we have negative 30 minus 5 times negative 6 gives us negative 30 plus 30, which is 0. And then what's negative 24 minus 6 times negative 4?
0.
0 as well, right? Oh, so we got a row of zeros, which means we're on a good track, right? Because what does this mean? It say again?
There's a solution for X and Y.
There's a solution for X and Y. There's a different. If your matrix is a 2 by 3 matrix, like in the previous example, that's right, it's only for that. But since we have a row of zeros here, that means that we have this form, which means we have a solution for X and Y. Okay? So good. So now what we want to do is we can make this 1 a 0. How can we make this 1 a 0? Talk loud, please. Do you want a fraction above? It doesn't matter. You said you want to do 1/5. You can. That works. It's legit. Oh my. Have to be smooth with this. Hate when it does that. Hey, we positioned it well. There we go. So, tell me what you said again. Which row are you changing?
Minus 1/5 R2.
So you're changing R1. So R1 minus 1/5 R2, you said?
Maybe plus.
I'm asking.
Plus 1/5 R2.
Plus 1/5 R2 to get a new what?
R1.
R1. Okay. Let's see what we get. So R1, why do I do that? R1 plus 1/5 times R2. So 1 plus 1/5 times 0 is what? 1, nice. Then 1 plus 1/5 times negative 5 gives us 0, good. So we get 0. And then we have 1 plus 1/5 times negative 4. That gives us, say it loud, 1/5, good. So we get 1/5 here. And then the second row, did that change? No, so we get 0, -5, -4, and then we have a row of zeros. Now we're close. What can we do now?
Divide by -5.
Or how do we say that? Multiply row 2 by -1/5. Good. So -1/5 times row 2 to get a new row 2. And that gives us, row 1 doesn't change, it's 1, 0, 1/5. Row 2 becomes what? 0, 1, and what's -1/5 times -4? 4/5, good. And then we have this row of zeros. So what can you tell me? How would you read this? How would you interpret it? Good. X equals 1/5 and y equals 4/5. Very good. So if you wanted to write down an ordered pair, it would be 1/5, comma, 4/5. That's a parentheses there. That's your solution. Very good. What questions do you have here? Okay. All right. So, one more example. One more example. You want to give it a try? Okay. And I'm writing random marks on the page. Let me erase that. So part C, you want to solve the system of equations. X plus 2y equals 1, 3x minus 2y equals -2, and 5x minus y equals 1/5. I'll give you a couple minutes to work it out. So we have this given system of equations. Now we want to solve it using the Gauss-Jordan method. So going about doing this, what's our augmented matrix? Not everybody at once. Thank you. Go ahead. Online, we got a volunteer as well. Go online. Good. And then you got it. Very good. Okay? Very good. So this is our augmented matrix. I'll put the dashed line because that's what you all like. Now, where did you start? Yes?
I multiplied
Row 3 by 5. So you have 5. You want me to write across? So 5, row 3 to get a new row 3. So you said, let's get rid of that fraction. Okay, row 2 change or row 1 change? Nope, so 1, 2, 1. 3, -2, -2. And what's row 3? 25, -5, and 1. Good. Okay, where did you go from here? Did you follow the same approach that we did in the previous example? So what was that approach? Creating what? You took your pivot, you said? Your pivot is the 1. And what are you doing? Creating what? Create zeros here and here. Good. How did you create zeros there? How'd you create a 0 where there's a 3? Yes?
For row 2, I said row 2 minus 3, row 1, and row 2.
Good. Row 2 minus 3, row 1 to get a new row 2. Row 1 isn't changing. So we have 1, 2, 1. Then what is row 2 becoming? 0, negative 8, negative 5. Good. So 3 minus 3 times 1 gives us 0. Negative 2 minus 2 or minus 3 times 2 gives us negative 8. And then negative 2 minus 3 times 1 gives us negative 5. Okay? Good. How did you change row 3?
Row 3 minus 25 times R1.
Good. Row 3 minus 25 row 1 to get a new R3. And what did you get?
0, negative 55, and negative 24.
0, negative 55, and negative 24. Good. So you would have 25 minus 25 times 1, 0. Negative 5 minus 25 times 2. So that's negative 5 minus 50. You get negative 55. And then 1 minus 25 times 1 gives us negative 24. Okay? Good. Now, what did you do? Did it get hard from here? Okay, so let me help you through that. Okay? So, what we can do now is, now we can create a 0 here and a 0 here. In order to do that, we're going to use this negative 8 as our pivot. So now, negative 8 is going to be our pivot. And what we're going to do is create zeros where we have a 2 and where we have negative 55. Okay? So now, do I need to write that or saying it is enough? Okay. All right, cool. So now, the way we do that, 2 is here. So in order for us to get this 2 to be a 0, we would like this, since this is negative 8, we can say row 2. We can say 4 times row 1, right? Plus row 2 to get a new row 1 would make this a 0. Okay? So 4 row 1 plus row 2 to get a new row 1. Sorry about that. How do I get off? There you go. Okay, so row 1 is now going to change. So we have 4 times 1 plus 0. What's that? 4. Good. Then we have 4 times 2 is 8 minus 8 is 0. Good. Then we have 4 times 1 is 4 minus 5 is negative 1. Good. Row 2, we're using row 2, so that's not going to change. It is what it is. Okay? That's a 5, negative 5. Okay? Now, negative 8 and negative 55 do not have anything in common. Okay? So what we're just going to do to create a 0 where there's a negative 55, we're going to take 8 times row 3 minus 55 times row 2 to get a new row 3. So we're just going to use the numbers here to create a 0 there. Does that make sense? Okay? So, using it, 8 times 0 minus 55 times 0 is what? 0. Good. What is 8 times 8 times, so on the side you have 8 times, hold on. You have 8 times negative 55 minus 55 times negative 8. So this is 8 times negative 55 plus 55 times 8. What are you going to get? 0, because they're opposites, right? You're going to get 0. So you get 0. Beautiful algebra. Okay? And then, whenever we have 8 times negative 24, so 8 times negative 24, so now we're looking at another entry, times or minus 55 times negative 5, what do you get here? What's 8 times negative 24 minus 55 times negative 5? What do you get? Very good. You get 83. Now looking at this matrix, what can you tell me? I see you doing your hand at the bottom. There's no solution. Good. There's no solution. Why?
Obviously 0 equals 83.
Very good. Row 3 says, or translates as 0 equals 83, which is false. So there is no solution. Yes?
So on a test, we like come across that step and see that right away. We just end right there.
You're done. You're done. There's no solution. At this point, anytime you end up with a false statement like this and you've already gotten zeros above and below the diagonal entries here, there has to be no solution. Okay? So if you get a matrix, so the observation at the bottom, if you get a matrix in this form where you have an entry, or you have entries up here, and then you have 0 and a number here, that means that you get no solution. Does that make sense? All right. That is all.